In this tutorial, we're going to talk about the slopes of parallel and perpendicular lines. So I first want to talk to you about parallel lines. Parallel lines has a very specific symbol that we can use for it, which is just two vertical lines. And what I know about parallel lines is that their slopes are always the same. And that's true for any pair of parallel lines. They will always have the same rise over run. For perpendicular, the symbol for perpendicular is an upside down capital T. Looks something like this, like two right angles. And in order for lines to be perpendicular, they have to have what's called opposite reciprocal slopes. Or, of the two lines, the product of their slopes is -1. So let's take a look at this example. It says, are these two lines parallel, perpendicular, or neither? So what we need to do first is make sure that any two lines are in the same form so that we can identify their slopes. And for line 1, L1, it says y equals 3x plus 1. And I know right off the bat, because this is in slope-intercept form, that 3 is my slope. So I want to see if line 2 has that same exact slope, but it's not in the same form. So I'm going to make it in the same form. Now, notice that in line 1, y is all by itself. So that's my goal, to put this function into slope-intercept form. So my process is going to be, I'm going to add 6x to both sides. This is my process of getting y all by itself. The 6 x's are going to cancel, and I'm left with 2y equals 2 plus 6x. And now what I'm going to do is I'm going to divide everything by 2. And that gives me y equals 2 divided by 2 is 1, and 6 divided by 2 is 3. Now notice right now that the coefficient of x is 3 as well, and that represents my slope. So these lines are in fact parallel. And the way I would formally write that out is like this. Line 1 is parallel to line 2. Let's take a look at another problem like this. Okay, so let's take a look at this problem. We've got two lines that are both in slope-intercept form, so I know what the slopes are right away. I have this as being 4/3, and this as being -3/4. Now, in order to be perpendicular, my slopes have to be what's called opposite reciprocal slopes. Opposite meaning the sign. So if one of them is positive, the other one must be negative. Reciprocal, as in, if I have 1/2, the reciprocal of that is 2/1. Now, are 4/3 and 3/4, -3/4, opposite reciprocal slopes? Well, if I took a look at their signs, 4/3 is positive, and -3/4 is negative. So they do meet the requirement that they are opposite. Are they reciprocals? Are they flipped fractions, 4/3 and then 3/4? Yes, they are. So this would be perpendicular lines. And I'm going to write it out formally for you. So line 1 is perpendicular to line 2. Now what about that other way where it said that the product of those two slopes is equal to -1? So let's see, if you didn't like the opposite reciprocal slope business, you could do 4/3 times -3/4. And if these are, in fact, perpendicular slopes, their product should be equal to -1. So I have a positive times a negative, which is a negative. 4 times 3 in the numerators is 12. And 3 times 4 in the denominators is also 12. And this reduces to -1. So once again, I've concluded that my lines are indeed perpendicular. And this concludes this tutorial.